Yes, sir.
Okay, that's great. So, Rumaisa, basically, we will be doing some the theory part, more CRISPR theory, along with the numericals. Okay. Okay, so let's start the class without any delay. Already, like we have waited a lot. Okay, so next thing is the basically that we'll be starting is the acceleration. So acceleration is basically nothing but the definition. Acceleration can be defined as the rate of change of velocity. Yes or no?
Yes, sir.
Rumaisa, am I clear?
Yes, sir.
Okay. Rate of change of velocity. So acceleration can be written as v minus u by t. Clear, everybody?
Yes, sir. Yes, sir.
Okay. So this is the acceleration, and basically, is acceleration is a vector quantity or a scalar quantity?
A scalar quantity.
Okay. Nabila said scalar.
Yes, sir.
Okay. What about Rumaisa?
Scalar, sir.
Okay, scalar. Okay. So velocity is a vector or a scalar? Yes. Acceleration.
Velocity is vector quantity.
Acceleration is a vector quantity, dear.
Okay, sir.
Because if we are talking about a velocity and the change in velocity, it means that the vector quantity formed will be sorry will be vector quantity. Clear?
Yes, sir.
Okay. Next is what is the SI unit of acceleration?
Meter per second.
Meter per second. Nabila, is this you?
Yes, sir.
Okay. Okay. Meter per second square. याद आया कुछ? Okay. So you were wrong. You were wrong, Nabila. And acceleration can be negative. Okay. So acceleration can be negative because it is a vector quantity. So it can be a negative. It can be negative as well. Clear, everybody?
Yes, sir.
Okay, very good. Okay, so basically two types of acceleration is there. Which first one is uniform acceleration. Uniform acceleration means a body acceleration. Basically, velocity increases by equal amounts in equal interval of time. That's what equal uniform acceleration is. If travels in a straight line, and its velocity increases by equal amounts. In equal time. ठीक है?
Okay, sir.
Of time. So example can be free fall motion. So a free fall motion is an example. Okay, because in that basically motion, a ball or a body gradually increase its velocity. Okay, in equal interval of time. Okay, free fall motion is an example.
Okay, sir.
Next is non-uniform. Okay, so non-uniform acceleration is basically a body has a non-uniform acceleration if it travels in a basically it does not have a straight line graph. Okay,
Okay, sir.
if its velocity increases by unequal amounts in equal interval of time. Clear? है?
Yes, sir.
Okay, so example can be there. Any example can be there, like if a motorcycle or a motorbike is stuck in a jam. Yes or no?
Yes, sir.
In a jam. Okay, so this is all about the acceleration. Clear, everybody? Please let me know.
Yes, sir. It's clear.
Clear. That's great.
Assalamualaikum, sir.
Walaikum assalam, Alvina. How are you?
Fine, thank you, sir. How are you? Sorry for
I'm
joining late.
no worries, dear. Okay, so I've started the acceleration part. Okay, so acceleration along with uniform and non-uniform acceleration. Okay, and this is the case that we will be doing in this chapter. Okay. Okay,
Yes, sir.
so okay, so you can take a screenshot once the class is over. Okay, Alvina. Okay.
Okay, sir.
Yeah. So let's do the thing. Next thing is that present is just a moment. The next thing, graphical representation of equation of motion. Okay, or you can say graphical representation of motion. Okay, so this is the topic in which two graphs are there in NCERT. First one is distance time graph. Okay, distance time graph. Clear?
Yes, sir.
And the second graph is velocity time graph. Clear?
Yes, sir.
Just a moment. So let's draw this graph and let's identify this graph tells you what. So this is a graph and the straight line is the slope of this graph. This is called distance. And this is time. Okay. And this is distance is in the direction. So suppose the thing that you have, suppose this is a point. This is a point S1. Okay. I'll not be going in detail because it's already discussed in class, because you know that thing we have very limited time. So, and this is T1, but I will giving you the overview of this topic. And this is that another after basically our distance is covered at, this is the point T2 and this is the time. Okay. So you can see this thing that for the distance S2, time is taken by the body is T2, and for the distance S1, time is basically is T1. So basically the slope whenever we talk about the slope of a graph, it's always y upon y, means y-axis upon x-axis. This is y-axis and this is x-axis. So if we need to calculate what it basically defines and what it basically represents, is that you can see this thing, final distance minus initial distance will give you the actual distance. If a body has started from this point and it has gone to this point, it means that the actual distance covered is this S2 minus S1, yes or no?
Yes, sir.
Yes, sir.
S2 minus S1 divided by, and the time taken by the body time taken by the body to cover the distance S2 is T2 minus T1 is the time taken by the body to cover S1 distance. It means that the actual distance body has started from this and it has gone from this point, it has gone to this point. It means that the difference between the time will give you the total time taken, yes or no?
Yes, sir.
So isn't it total distance by total time or the actual distance by time? What it
Yes,
basically
sir.
gives you, it's give you the speed. Yes or no? Clear, everybody?
Yes, sir. It's clear.
Any doubt?
No, sir.
Okay. So this is the distance time graph. And the next is basically, just a moment. Next is velocity. Time graph. So velocity time graph is like this. Okay. So in the y-axis, velocity is, and this is time. So velocity time graph, basically suppose that if a body has a velocity and it is basically it's moving with a constant velocity, we are basically talking about a uniform motion. Okay, so if a body is moving with a constant velocity, so it will cover equal distances in equal time. Suppose that a body has started from this point, basically let's find out the how much distance it will cover in a certain time. What you do is that, suppose that this is the time T1 and this is the time T2. Let's denote this T2 and this denote this T1. And this is the V velocity and this is the 0. Okay. Origin, yes or no?
Yes, sir.
Okay. As you can see this thing, the graph, this part, if you take the area, basically, this will give you yeah. So as you can see this thing, this if you take the region, this region, because There isn't any slope. The slope is 0. But if you take the area of this graph, velocity into time will give you what? Can anybody tell me? Velocity into time is what? Yes? Who said like somebody has said something? Okay, see this thing. Velocity. Yes, please speak. Rumaisa, yes, Rumaisa. Rumaisa, you're speaking some. Okay, so yeah, you can say displacement or distance. It depends on the situation or according to the question. Okay, okay. Answer is correct. Very good. Okay, so basically, see this thing. Velocity is there. So basically, basically the different basic actual velocity is v1. This is v and minus 0. Yes or no?
Yes, sir.
Because there isn't any initial velocity, so 0 is there. So v minus 0, it's nothing but v. So this area of graph will give you equals to distance. Okay, is equals to v. Area is what? This is b and this is L. So basically, let me give you. So in like it is not fixed that it will be a square or rectangle or something. It can be anything. It can be a trapezium. It can be a triangle. It can be a parallelogram. It can be anything. Clear? So it depends on the question. I've just taken this square, the rectangle one, that is L into B will be equals to L is what yours? L is the T2 minus T1, yes or no? The actual time taken. T2 minus T1 into B. B is what? V minus 0, that is nothing but V. So you can see this thing, the velocity into time is nothing but speed, basically distance. That is S. Yes or no?
Yes, sir.
Yes, sir.
Okay. Yeah. So these two graphs are there in your syllabus. Okay. Next topic, that is once we do the equation of motion, okay, then we'll be doing some numericals of this chapter. Does anybody have any doubt? Please let me know. This is also like you can also ask the doubt if you have.
No, sir.
Sure.
Yes, sir.
Okay, that's great. So how many equations of motions are there?
3.
3. Very good. Okay, that's great. Are this equation of motion valid in like in which of the motion uniformly accelerated or non-uniformly accelerated?
Uniformly.
Yes, these motion equations of motion are basically applicable in uniformly accelerated motion. So basically, first equation of motion is u plus at, v is equals to u plus at. Second is s is equals to ut. Third is v square minus u square is equals to 2 as. Clear? These are the 3 equations of motion. Clear, everybody? Yes or no? Please let me know.
Yes, sir. It's clear.
Yes.
Oh, that's great. Just giving you, let's solve one question based on this. What is the v in this equation? What is v in this equation? Can anybody tell me? What does v denotes?
Velocity or speed.
So what is u?
Initial.
V is final velocity and U is initial velocity.
Very good. V is final and u is initial. Very good. What is a? A is
Acceleration.
acceleration. S is distance and T is time taken. Okay, let's do this question. A scooter acquires a velocity of 36 meter per hour in 10 seconds just after the start. So what will be the initial velocity of this?
0.
0. Very good. And the V is given as 36 kilometer per hour. And by if you need to convert this into basically a meter per second, you just have to multiply this number, kilometer per hour number, by 5 into 18. So this number will get basically convert this thing into meter per second. So 18 to the 36, so that is 10 meter per second. Clear? So this is, you need to calculate the acceleration of the scooter. What in so in which equation you can use?
V equal.
And time is also given, that is 10 second. Okay, so you can use the equation that is V is equals to, so V is equals to, so V is 10 is equals to U plus A is what? A you need to calculate and into 10. So 10A is equals to 10. So A is equals to 1 meter per second square. Is this clear to all of you? Yes or no? Please let me know.
Yes, that's clear.
Okay, let's do some questions. Okay, now I'm giving you this question to you. 2 minutes for this question, not more than that. This is, I've, okay. This is 10:01 in here. So I will, you will stop by 10:03. Solve this one. Okay, Nabila. What about rest of you, Albina and Rumesa?
Done, sir.
Done? That's great. Okay, let's solve this question. So basically, this question is saying that the negative acceleration is given to you. It means that the retardation is there. A body has basically stops after some distance or some motion. So horizontal surface, that is 0.5 meter. Initial velocity is given as 0.5 meter per second, and acceleration is given as minus of 0.05 meter per second square. So we need to calculate how much time is required. So, and the final velocity will be zero because it has stopped after some time. Okay. So which equation can we use?
V equal to U plus AT.
Yes, very good. Because it's all the three quantities are there. So only the time, basically, time is required to calculate. So V 0, 0.5 minus of 0.05 into t. So it is equals to 0.05 into t is equals to 0.5. So when you divide this thing, so it would be 0.05, 0.05. Okay, so remove this decimal, only 110 will get multiplied. Remove this decimal, 100 will get multiplied. So this 10 will cancel this, 100 will cancel this one, and this will cancel this 5. So 10 seconds is the answer. Clear, everybody? Please let me know.
Yes, sir.
Any doubt?
No, sir.
Okay. So one more question is there. Do this one. Any answer? Nabila, Rumaisa, Alvina?
Yes, sir.
Okay. Okay, let's find it out. Basically, this question is saying that a car is traveling at a speed of 20 kilometer per hour. Already the car has some speed. What will be the initial velocity of this car?
Initial is 20.
20 kilometer per second. Okay. So you have to convert this into meter per second. Just multiply it by 5 by 18. So 10, 9. So it is equals to 50 by 9 meter per second. And 60 is the final velocity. And 60 equals to 60 into 18. 5 by 18. 9 and 30 and 10 and 3. So it is equals to, okay, just don't multiply the 30 by 9. ऐसे रहने देते हैं क्योंकि 9 और 9 होगा ना तो सब्ट्रैक्शन में ज़्यादा आसानी होगी. So this is equals to 150 by 9 meter per second. We need to calculate for the acceleration. T is given as 6 seconds. Clear? So V is equals to U plus 80. So V is equals to 150 by 9 minus U is 50 by 9 is equals to A. We need to calculate T is 6. So it would be equals to 100 by 9, yes or no? Is equals to A into 6. So A would be equals to 100 by 9 into 6. Not it will get multiplied, not divided into 6. So it is equals to 3 and 50. So yeah, it equals to 50 by 18 meter per second square. So last question, just a second, based on the okay, this is the question. Yeah, this is the question. Solve this one and then we'll start the uniform circular motion. Any answer? Nabila, Alvina, and Rumaisa?
100 meters, sir.
Okay. It took a long time to solve. Why? Okay, let's solve it. So the speed at which basically the scooter is moving is 10 meter per second. Okay, so it is initial or final? It is initial. V is 0 and acceleration which is given is 0.5 meter per second square. Negative is why? Because the acceleration, basically the speed is decreasing. Clear? The acceleration is basically is in the opposite direction of motion. Clear? And we need to calculate the distance. So which equation should we use to calculate this?
Third one.
V square minus U square is equals to 2AS. Very good. So V square is 0 minus of 10 square is equals to 2 into negative of 0.5 into S. So this is nothing but, so this is negative of 100 is equals to minus 2 into 0.5 is nothing but 1 into S. So this negative will cancel this negative. So S is equals to 100 meter. Is this clear to everybody? Please let me know.
Yes, sir. It's clear.
Nabila, Rumaisa, Alvina, is this clear?
Yes, sir, it's clear.
Okay,
Yes,
that's
sir.
great. So let's, yeah, Rumaisa, you were saying something?
No, sir.
Okay. So let's talk about the next topic, that is uniform circular motion. So uniform circular motion means it may basically your body is moving in a circular motion. Clear? So and what is uniform? Uniform means basically the velocity is not changing, but the direction is changing. Clear?
Yes, sir.
Okay. So basically this in this type of motion, the velocity is uniform or constant basically. Okay. Let me write it down here. When a body moves along a circular path, then its direction of motion keeps changing continuously. Yeah. So this is the uniform accelerated motion. And one more thing is that when a body path with uniform speed. Uniform speed means constant speed. Its motion is called uniform circular motion. Clear?
Yes, sir.
Okay. So even the speed, basically the velocity is constant, but the circular motion is accelerated because why it is accelerated? Can anybody tell me? Because direction is continuously changing. Acceleration can be of two types. So in one acceleration, the speed is changing, but in one acceleration, this direction is changing. In I like if any of the quantity is changing, either it is speed or direction, it will be accelerated. Clear?
Yes, sir.
Clear?
Yes, sir.
Okay, so example of this motion can be stone tied to a thread. Clear? And one more thing is
Yes, sir.
that the force that is required to move an object into circular path, that force is called as centripetal force. Clear?
Yes, sir.
An object circular path is called centripetal force. Okay, and real world like application of this is artificial satellites in the orbits. So artificial, you have seen that artificial satellites continuously moves without any external force.
Yes, sir.
So the force that basically moves the satellite into a circular motion. Okay. Artificial satellite. Clear? Any doubt? So if anybody says that is a uniform circular motion is accelerated or not, so what will you say?
Yes, it is.
Why?
Because it's having direction because of the circular motion
Because
is
of the
being
change in direction. So
okay.
if either basically magnitude or direction changes of a vector quantity, or sorry, of a speed basically, so basically there will be accelerated motion. That motion will be considered as accelerated motion. Clear, everybody? Please let me know.
Yes, sir. It's clear.
Any doubt? Sure.
Sure, sir.
Okay, just allow me a moment. Okay, please answer this question to me. Which of the following is most likely not a case of uniform circular motion? Nabila, Alvina, Rumesa, please let me know the answer.
Option C.
Okay, Nabila said option C. What about rest of you, Rumesa and Alvina?
Sir, option D.
Option D by Alvina.
Yes.
Okay, Rumesa, what's your answer?
Sir, option C.
Option C. So Al-Nabila and Rumaisa said option C, Alvina said option D. So the correct option is C, because the motion of our hand is uniform dear. Only you can see that it's moved with a constant speed. But on a racing car, when you talk about the motion of a racing car on a circular track, so you cannot predict from by which velocity it is moving. Clear? Because its speed is continuously changing. Racing car, it's real world basically implementation. Clear? Okay.
Yes, sir.
Yes, sir.
Okay, so that's all for this class, and that is that is all about this chapter. Motion chapter is done in the revision classes. So in the next class, we'll be starting the force and laws of motion. Please revise the concepts before coming to the class, and then we'll start it. Okay. So let's end the class right there. Okay, take care everybody. Take care, assalamu alaikum, and take care everybody.
Thank you, sir. Bye. Assalamu alaikum.
Well,
Wa alaikum
Walaikum assalam.
I like it, sir.
Walaikum assalam.